Assalamualaikum and hi, my name is Filza Shazwan Mifazwil, and today I would like to make a project presentation about component remanufacturing. So our group consists of three members, which is Adam bin Azman, myself Filza Shazwan Mifazwil, and Muhammad Afiq Iman bin Muhammad Fauzi. So for introduction, additive manufacturing describes the use of 3D printing to make functional components, including tools and end-use production part, where additive manufacturing builds geometries by adding feedstock such as filament, wire, or powder. Additive manufacturing has been shown to be a good option in production application where long lead times or associated costs preclude the use of expensive tooling. Complexity of geometry is advantageous and or low volume are required, though the quantities appropriate for 3D printing continues to increase. So what are the difference between additive manufacturing and conventional methods? So there are three differences, which is the first one is creating complex geometry. The basic physical difference in how objectives are made with additive manufacturing also produce some major functional difference. The most important of this functional difference is that additive manufacturing can be used to create complex geometries that would be difficult or impossible to achieve with conventional methods. The second one is other functional differences. Another major functional differences between additive and conventional methods in the fact that additive manufacturing involves far less material waste. We effectively render a material waste byproduct when removing in a subtractive manufacturing process. Additive manufacturing uses the material necessary to create a part, ensuring the waste is very minimal. And the last one is differences in the equipment required. Additive manufacturing also differs from traditional manufacturing methods in terms of technology that we use to facilitate it. Traditional manufacturing process can often require several steps, each using a different machine. In metal machining, for example, turning, milling, and drilling are frequently used in concert or to create a finished metal part. So for additive manufacturing for car components, so there are four types of technology, which is fused deposition molding, stereolithography, selective laser sintering, and last one electron beam melting. So the target components for fused deposition modeling is component vehicle design prototyping, emission filter and filter housing, and physical model of fuel door, dashboard, and gauge port, fork tube covers, headlight, bezel, mounts, and else. So for stereolithography, they produce gear shift knobs, prototypes of pneumatic and hydraulic system, transparent prototypes for engine components and tooling device, and body kits and bumper for a vehicle manifold and covers. So for selective laser sintering, target components which is gearbox prototypes, grills and fender, fuel tanks, small engine components, hydraulic actuator system, rapid prototyping, and low volume parts and tubes and knots. So lastly, for electron beam melting, the target components is pump, wheel rims, small compressor components, frame construction, variable density system, and turbine blades. So for additive manufacturing advantages, metal additive manufacturing isn't just technology for technologies. There are indeed functional benefit of the additive manufacturing process, which is rare shape making ability, manufacturing plus assembly in one. So in manufacturing plus assembly one, an additive manufacturing line can produce multiple components at a time in a same build box instead of creating individual parts that assembling them at a later point. And so the last one is no tooling cost. So for additive manufacturing disadvantages, many of the benefits of additive manufacturing already exist in powder metallurgy. Just in a more subtle form, you have to decide whether modest improvement in those areas are worth the disadvantages associated with 3D printing, such as there are, for example, which is expensive part cost, surface finish, dimension control, and is slow and has size limitation. So the objective is for the project is to compare the material properties of additive manufacturing and conventional manufacturing materials.
Assalamualaikum and good morning. My name is Adam bin Azman. Okay, the method we use on this project is to use SolidWorks software because to produce any item from a 3D printing must have a 2D drawing or 3D drawing and be saved in the form of a DWG or STL file before beginning set in a 3D printing machine. The model is a fuel deposit modeling FDM. Okay, the process flowchart our project. Okay, first we start and select the CAD model version, SolidWorks, and then sketch the design and follow the mission and make a 2D and 3D drawing. Okay, if need modification, we make again 2D and 3D drawing. If no, we save in DWG and STL file and input the data STL file to the 3D printing machine FDM. Okay, next, this one is a 2D and 3D drawing with our project specimen. Okay, for the this one is the tensile test, and then this one is the impact test for the 2D and 3D drawing our project. Okay, the type material we use on this project have five. The first PLA Pro Green 20% and polycarbonate 100%, ABS Pro Red 100%, ASA Black 20%, and mixed steel. So this is a type of material we use on this our project. Okay, next result and discussion. Okay, the result in this table are the result after performing the tensile test and measure using vernier caliper before and after. Okay, we can see in the measurement section before that all specimens are the same and they are different in the result according to the material. As we see the data show, the elongation for the all specimen for the all results show not too long and too different from the others. Okay, this one is the impact test result of our project. Okay, based on the data, we found that the percentage of the material used can cause the difference in strength, and the data record can be compared with other materials in a graph chart. Test specimen before test and after test for tensile test and impact test. Okay, based on the result of observation for the result before and after performing the test. Okay, it was found that the material we use in this project have give a different result and outcome. Okay, such as ASA Black, PLA Pro Green, ABS Pro Red. Okay, on the tensile test show the result, the specimen will be elongated and just cracked. And for polycarbonate and mixed steel, the results show the tensile test specimen have an impact test also show they are cracked after test. Okay, for the impact test, other materials only crack and still strong. This shows that the selection of material is very important and need to be tested before the material is used on our project.
Assalamualaikum and hi. I am Muhammad Afiq Iman and today I am going to present about the analyze the value and the significance of area of V notch. Okay, so as you can see, this is the graph of the final energy. So the graph above shows the final energy of all the materials that have been tested by all three groups. As shown in the graph, the mild steel is the highest as it could go up to 30.256%, 11.83% and 9.89%. Then it comes to the ASA black as we three groups get 1.011%, 0.83% and 0.787% each. Then it comes to the ABS Pro rate, which we three groups get 0.64%, 0.49% and 0.505% each. Then finally the last one is followed by the lowest, which are PLA Group, Pro Green and Polycarbonate, as their results are the lowest with little differences in the graph. For the second graph that I posted in this slideshow, it is the absorbed energy. Okay, so the graph above shows the absorbed energy of all the materials that have been tested by three groups. The highest reading that we get is the mild steel, which are 60.6%, 23.68% and 19.82%. Next, we get the ASA black as the second highest, which are 2.03%, 1.66% and 1.58%. Then, the third one is the ABS Pro rate, which are 1.27%, 1.01% and 0.96%. The lowest readings are PLO green and polycarbonate, which have a bit differences in the graph. For the third graph is the impact strength. So the graph above shows the impact strength of all the materials tested by three groups. The highest reading that we three groups achieve is the mild steel, as the readings are 0.2%, 0.05% and 0.03%. The next highest reading that we achieve are the ASA black, which are 0.005%, 0.03% and 0.002%. The third one is polycarbonate, as we get 0.003% and there are two of 0.002%. The lowest reading of the materials that we have tested are the PLO Pro Green and the ABS Pro Red, and they both have a slightly bit difference with each other. Now for the question, which is discuss and conclusion based on effect of welding process, visual inspection that enhance or influence the overall impact test result. Okay, the answer is the result of the implant process shows that it is less suitable for the iron material use. This is because it affects the test result of the tensile test and the impact test. As a result of our observation, found that the result of tests performed on the material that is welded can still find data and can be compared with other material data. Okay, so for now, I will present about the analysis of the tensile test. Okay, the graph above shows is about the ASA black. So, the graph above shows that the 100%, which is the red color, is the strongest as the force applied to it is more than 1000 Nm, while the stroke is just past 2. Then, the second one is the 50%, which is the yellow color, as the force applied to it is just below 1000 Nm, while the stroke is just before 3.5. Then, the weakest is the 20%, which is the blue color, as the force applied to it is just above the 800 Nm, while the stroke is past 2. So, the next best material is the ASA black 100%, as it is the strongest. So, next is the graph about the ABS Pro rate. Okay, so the graph above shows that the 100%, which is the blue color, is the strongest, as the force applied to it is above the 1200 Nm, while the stroke is just above 2. Then, the second one is the 50%, which is the red color, as the force applied to it is above 1000 Nm, while the stroke is past 2.5. The weakest is the 20%, as the force applied to it is just below 1000 Nm, while the stroke is just past 2.5. The next best material is the ABS Pro rate 100%, as it is the strongest of them all. Okay, so now we move on to the PLA Pro Green. Okay, so the graph above shows that the strongest is the 100%, which is the grey color, as the force applied to it is above 700 Nm, while the stroke is just past 14. Then the second one is the 50%, which is the red color, as the force applied to it is just at 600 Nm, while the stroke is just past 6. So the weakest is the 20%, which is the blue color, as the force applied to it is above 500 Nm, while the stroke is past 12. So in conclusion, the next best material is the PLA Pro Green 100%, as it is the strongest of them all. Now for the last graph, which is the polycarbonate. Okay, so the graph above shows that the strongest is the 100%, which is the grey color, as the force applied to it is above 1000 Nm, while the stroke is past 1.5. Then the second one is the 50%, which is the red color, as the force applied to it is just at 1000 Nm, while the stroke is past 2. The weakest of them all is the 20%, which is the blue color, as the force applied to it is just at 800, while the stroke is past 2. So in conclusion, the next best material is the polycarbonate 100%, as it is the strongest. Okay, so now we jump into the conclusion. Additive manufacturing describes the use of 3D printing to make functional components, including tools and end-use production parts. Additive manufacturing is a powerful force changing how we make parts and products in many different industries. There are different additive manufacturing technologies that are developed according to specific components, areas, production requirements of the automotive industry. Also, advantages and disadvantages is a must in every technologies. As in this report, we have conducted some tests, which is tensile and impact tests on our product. The product that we are use are different materials, and it also have different percentages. The results of the data will show the materials and percentages used, which are strong and suitable for use on vehicle components, parts, or in automotive manufacturing. As the results that we get, we now have found the right and suitable materials which is strong to use in automotive manufacturing. So that is all from us for now. So thank you.